I've touched on simulation theory a few times already on the channel, but I want to fall back a bit and discuss how established phenomena lends credence to the idea that we do indeed exist in a complex virtual digital construct. The idea that we live in a virtual digital construct is more than just a movie trope or an abstract thought experiment dreamed up by long-dead philosophers. There's an abundance of compelling ideas floating around out there supporting the notion, and I'm going to lay out a bunch of them here. I'm not going to go over Nick Bostrom's simulation argument. Bostrom's argument is what I consider to be the most compelling argument for simulation theory, but it deserves a video all on its own. However, I feel it's been well discussed. If you'd like me to do a video with my take on Bostrom's work, let me know in the comment section below. Now before we go any further down this foxhole, I want to thank everyone who has subscribed. I really am having fun putting these videos together and would not be near as fun without you. Thank you. And if you haven't already, please subscribe, join the conversation. Moving on. One established phenomenon that can be interpreted in a much different way when viewed through a simulation theorist lens is what astrophysicists refer to as the Big Bang. You may have heard of it. It's well established that the Big Bang happened, but beyond that, the theory does not tell us much about the nature of reality. In fact, it creates more questions than it answers. Like, what was before the Big Bang, and where did all this stuff floating around come from? One of my favorite hackers, George Hotz, in a talk he gave about breaking out of the simulation, declared that the Big Bang is not an answer. I tend to agree. It's an observed phenomenon, but by no means is it an answer. So, how does the Big Bang lend credence to simulation theory? Consider what happens when you boot up an operating system on any machine you may enjoy. It starts at a zero state. There is nothing. Then, in a very short amount of time, boom, everything is there. Literally everything you need for the environment to work. Well, unless you're using Windows. What we know as the Big Bang may very well have been the simulation simply booting up. This seems so intuitive that when I first heard of the idea, it really struck me. It's one of the ideas that convinced me to look deeper at the whole idea that we exist in a simulation. Another observed phenomena that lends credence to simulation theory is what we refer to as quantum entanglement. Quantum entanglement is the phenomenon that Einstein admitted existed but referred to as spooky action at a distance. When two or more particles become entangled, what happens to one particle instantly has an effect on the other particles, no matter the distance between them. So, one particle could be sitting in your coffee cup, and another particle that is entangled with it could be on the other side of the universe, some 3.5 trillion light years away, and instantly change, despite that insane distance, appearing to break one of our universal constants, the speed of light. Data must be exchanged somehow, and that data must move faster than the speed of light. Or, something else is going on, and perhaps that something else is linked to a fundamental attribute of reality. If nothing can travel faster than the speed of light, then what is happening when we observe two entangled particles instantly reacting to changes, no matter their distance from one another? This is one of the biggest questions in physics, but is anecdotally answered by simulation theory. Consider looking at a picture on your device. Now imagine all the pixels that make up the picture you're looking at are entangled. Now apply a filter to that picture. Does each pixel change individually, or does the filter apply to every pixel immediately, no matter the distance from each other on the screen? Something similar may be happening in our reality, only on a much broader scale and in many more complex ways. Talking about pixels, I want to talk about Max Plonk a little bit. Plonk was convinced our reality was pixelated before pixels were even dreamed up. He managed to find the smallest unit of measurement possible, which was named the Plonk length. It's 1.616229 times 38 times 10 to the negative 35th power meters long. It's really small, and is what I declare as my favorite number. For the record, I have a whole filing cabinet at home full of things that don't exist, and I count half a Plonk length as part of my collection, right in there with the Brontosaurus and a good Teenage Mutant Ninja Turtles movie. But I digress. Pair a Plonk length up with a Plonk second, the time it takes light to traverse a Plonk length, and you get something akin to a single frame in a movie. Slow everything down, as slow as it can possibly go, and things are not smooth, like the way we perceive things, but can be measured out in discrete sections, like a single frame in a movie. There is a lot of established knowledge that lends credence to simulation theory. I think Claude Shannon's work on information theory is an example of that knowledge. Information theory, in a nutshell, states that everything is information, from the pixels on your screens, to the atoms that make up your body, to the energy spewing from our sun. Everything is information. Thomas Campbell, a respected physicist who spent a good chunk of his career developing missile defense systems for the US military, is conducting experiments right now in an attempt to prove that everything is information. He's dreamed up another version of the double slit experiment that, if successful, is going to make some waves in academia, or most likely get buried because the implications of his work will be astounding and probably difficult for our current body of scientists to accept. Perhaps, thanks to Bostrom's work and big brains like Elon Musk and Neil deGrasse Tyson lending their voices to the possibility, academia will have a more measured and legitimate look at the data. I certainly hope so. At a high level, I think the most established knowledge that lends credence to simulation theory is the fact that our universe appears to be created and tuned in a specific way to bring about what we perceive as reality. I'm talking about the universal constants, like the speed of light, Planck's constant, and absolute zero, to name a few. There's only a few dozen phenomena that come together to make the reality around us. The odds of everything coming together, by chance, in just the right way over billions of years spanning trillions of light years is frankly unbelievable. This has to be on purpose, and if that's the case, then something did it. So, when people talk about creationism, my ears perk up. Even biblical explanations take on a new meaning, and I find I can have a better conversation with people who believe in creationism when I frame it with simulation theory in mind. When I think about what we do know and how crazy that is, then making the jump to simulation theory does not feel all that odd. This is our story. We exist in a tiny sliver of habitable space, on a planet perfectly tuned for life, in a cosmos that is unfathomably large. We are barreling through space at dizzying speeds, locked in an orbit around a massive star that is also hurtling through our cosmos. Wait but a single Plonk second and we will have traveled, together, an insane distance without even getting out of our chairs. We are likely but one of millions of intelligent species in the universe, separated by both gigantic spaces and deep time, yet we can still conceive of each other and yearn to connect. Everything you see around you is the product of star stuff. The bones in your body, the air you breathe, and the food you eat all have the same origins, going back billions of years. We are all connected in our experiences in this reality and by the information we observe around us. This is all established, and the story we tell ourselves every day. Is it so crazy to entertain the idea that the lattice this insane reality is built upon is an intentional digital construct? Thank you for listening. If you like my work, please hit that like button and consider subscribing. And remember, this ride is not without risk. Be careful out there, and take care.